Okay, so good morning all of you. We are back to the session of periodic table, and the first three periods and the first three periods and the fourth period up to calcium, I have told you that this is what you need to know for your school purpose. Okay, so in periodic table, in our last session, what we did was that we basically discussed about valency, that when you go across a period, then valency, like when you go across a period, then valency first increases and then it decreases. That's what we had discussed. Now, the point is that this is the first period, first group hydrogen, right? And then in the same period the last element is helium, and then second period lithium, beryllium, and so on. So what happens to the size of an atom when you are going across a period or when you are going down a group? What happens to the size of an atom? That is what we are going to discuss today, right? So basically it's like this, that as you are going from hydrogen to helium, so you are going from left to right, so you know that the atomic number is increasing in any period. As you go from left to right, the atomic number is obviously increasing by 1 unit. That you all know. For example, lithium atomic number is 3, beryllium is 4, boron is 5. So as you go from left to right, the atomic number is increasing by 1 unit. Now you know that atomic number is a marker of number of protons. So if the atomic number is increasing by 1 unit, what it means is that the number of protons is increasing by 1. So the number of shells is not changing. For example, when you are in the second period, this is 2, 1, this is 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. So all of them have 2 shells. Similarly, this first period 1 and this is 2, so there is 1 shell. Third period, 281, 282, 283, 284, 285, 286, 287, 288. So you have 3 shells. So in a particular period, the number of shells is the same. In the second period, there are 2 shells. In the first period, there is 1 shell. In the third period, there are 3 shells. In the fourth period, there are 4 shells. So the number of shells is not changing when you are going across a period, but the number of protons is increasing. So number of shells is the same, but number of protons is increasing. As a result of that, the nuclear attraction becomes stronger as you go across a period. And as a result of that, the outermost electron is more strongly held as you go across a period. That means the size of the atom decreases as you go across a period. So as you go across any period, the size of the atom decreases. So as you go across second period, third period, the size of the atom decreases. On the other hand, if you are suppose going down a group, okay, if you are going down a group, suppose you are going down group 13. So when you are going down a group, what is happening? So boron is 2, 3, aluminium is 2, 8, 3. So as you are going down a group, the number of electrons in the last shell is the same. When you are going down from boron to aluminium, the number of electrons in the last shell in both the cases is 3. But here there are 2 shells, here there are 3 shells. Similarly, when you are going from carbon to silicon, the number of electrons in the last shell over here is 4, here is also 4, but the number of shells is increasing. In carbon there are 2, in silicon there are 4 shells. So as you go down a particular group, the number of shells is increasing by 1, but the number of electrons in the outermost shell is the same. So what we can say is that as you are going down the group, although there is an increase in atomic number, although there is an increase in the nuclear charge, but the number of shells is becoming more, and out of the two effects, increase in nuclear charge and number of shells is found to have a greater impact, and therefore as you go down the group, the size of the atom increases, right? So this is the topic for today's session, that in the periodic table, whenever you are traveling across any period from left to right, the number of shells is the same, but the atomic number is increasing by 1 unit as you go from one element to the other. and as a result of that, the nuclear attraction is becoming more as you go from left to right. So overall impact is that the size reduces as you go from left to right. On the other hand, when you are in a group, as you go from the top of the group downwards, what happens is that the number of shells is increasing by 1, but the number of electrons in the outermost shell is the same. That means as you are going down any group, the effective nuclear charge is becoming more. That's true. But the number of shell is also becoming more, and out of these two contradictory effects, number of shells has a greater impact. So as you go down the group, the size of the atom increases. So size of atom increases across a period. Decreases across a period. Size of atom increases down the group. So size of atom decreases across a period and size of atom increases down a group. So this is how we justify the change in size of an atom across a period or down a group. So based on this, your homework is okay, so this is your homework. There are 5 elements. You have to arrange them in increasing order of atomic size. Lithium, boron, nitrogen, phosphorus and chlorine. So this is your homework for today. Arrange these 5 elements, lithium, boron, nitrogen, phosphorus and chlorine in increasing order of atomic size. This is your homework, and that will be all for this session. I'll end the session now. Bye all of you.